Good afternoon and welcome to the 14th At Right Angles webinar. Many of you have been readers of At Right Angles for many years. But for the benefit of those who are joining us for the first time, let me introduce the publication to you. It's a joint publication of Azim Premji University and Community Mathematics Center, Rishi Valley. We've been publishing since 2011, and we bring out 3 issues a year in March, July, and November. We have with us 2 authors who have contributed to the July 2021 issue. They are Aaloka Kanhere and Krittika Hazra. Krittika has actually provided the text for our very first comic strip cartoon article. It is not a text article, but in the style of a graphic novel. And the reason we presented it in this format was because the text was full of conversations. So both Krittika and Aaloka are doing a lot of interesting work in the field of math pedagogy. And I'd like to ask Krittika to share a little bit about the work that she does.
Hello, I am Krittika Hazra. I teach in the Future Foundation School, Kolkata, and work with classes 6, 7, and 8. I started my teaching career in Sahyadri School, Krishnamurti Foundation of India, and I started teaching or started loving teaching maths from there. So I try to make the teaching learning process more relevant to the students. And here I am today to share some of the experiences from there.
Thank you, Krittika. Thank you, Krittika. Now we have Aaloka Kanhere. Aaloka had contributed the article Children's Algorithms, and both these articles have a lot in common, as you will find out during the webinar. But before we start, Aaloka, can you share a little bit about the work that you do?
I have been part of a project called Vigyan Pratibha, which is under the Homeova Center for Science Education, HPCSC. And this is a project where it is designed to encourage class 8th, 9th, and 10th standard students to do school mathematics and science. So this is also meant for children who are interested in maths and science, and not children who do well assessment-wise. So before that, I have also been in Eklavya, where I worked with a group of middle school children in the Betul district. So some of the examples are also from there. Some examples are from Vigyan Pratibha. I have a background in mathematics, and then have had the experience, have the privilege of working with institutions like Eklavya and HBCSC for a long time. So yeah, that's about it.
Welcome to both of you. And let's get started because I know you both have a lot to share. So I'll start with Aaloka, and the question is the same to both of you. How do you open up opportunities to get children talking? So Aaloka, can you share first?
Yeah. Just 1 minute. There's some.
Sure.
Yeah.
You would have noticed in Aaloka's article that the entire article was focused on children sharing the algorithms that they use. So I thought it was an appropriate first question for her. How do you open up opportunities to get children talking?
So yeah. Can you see my presentation?
Yes.
Yeah. So there are a lot of strategies I think teachers use, some very thoughtfully and some that just happen and are very organic. The two things that I have kind of explicitly thought about and seen good teachers do, and then also try to implement it in my way, are also asking the question why. So basically, setting a culture of justification. So not just being satisfied with whether the answer is right or wrong, but also why, and why is the student thinking of it in that way. The second one is asking open questions, questions which are not open only in answers. So it's not that there's multiple answers to the question, but also that there's a possibility of multiple approaches, and hence it gives you an opening to discuss in the classroom. So both of them together is what works. I'll talk about some examples. So let me start with something about why asking why helps. So this was a question given to the children. We were doing a lot of patterns, and this was a part of the ongoing pattern work course that we were doing. And so there was a table given, and it was complete the table and justify your answers. So because these were class 5 children and they were not used to variables, so we used to use the word number for a general term instead of n or x or something like that. So this was the question, and so these were students answers. So 3 plus 2 plus 3 into n minus number minus 1, 2 plus 3 into number, 3 into number plus 1 minus 1. So these were the answers, and when I translate it in algebra, these are the in a of that. Now, as a teacher, when I had actually solved this, my answer was 5 plus 3 into n minus 1, which was basically looking at the first 5 term and then the addition of 3 at every term. And I could see that all the 3 are equal to my answer. So in theory, all of them were correct. But I went on to actually, because the children were told to justify, so they went on to justifying their own answers. So um, the first was 3 plus 2 plus 3 into n minus 1, and this child goes as 3 plus 2, then 3 plus 2 plus 3, which is a new addition, and she goes on to add the 3's in red. So hence the answer is 3 plus 2 plus 3 into n minus 1 for the nth design. So of course they used to say Sankhya. Sankhya or ek Sankhya se ek kam. That's one less than the number. That is how the children used to say. But the next problem, the next answer, 3 into n plus 1 minus 1, intrigued me also, because I was not very sure how she was actually counting it, and how she was getting how was she getting the 3 into n plus 1 minus 1. So when I asked her to justify her answer, what she did was she said she added a matchstick in every term. And why did she do that? She said because she wanted 3 and then another 3. So the three or 2 copies of 3. And then what she saw was that in every one time there was one copy of 3 getting added. So in the nth design, you will have already n copies of 3, and then there will be one more copy of 3. So it's 3 into n plus 1. So hence, this is the answer for the new pattern that she created. And hence, then she goes on to say that now because I've added one, I have to remove it. So that's why the minus 1 in every term. So, I mean, this was absolutely interesting, and I had never myself thought about manipulating the pattern I gave, because, like for me, the pattern was sacrosanct, and all the manipulation was in the answers. So this was very nice to see actually, that she actually manipulated the given pattern itself. But more importantly, what it gave us was also a strategy gave us, and since me and the children, a strategy to solve future problems of patterns, where you could actually manipulate patterns to get more comfortable numbers, and then go on to generalize it. So yeah, so I mean, this is one example how children, like, how one can get children to communicate in the classroom, and how it works and how it helps. Yeah, thanks a lot, Sneha.
Thank you, Aloka. Absolutely fascinating. That strategy of adding the stick is almost like what we do in geometry when we do a construction, and then it all becomes so clear. But here we
Yeah.
see the child doing this in algebra. And did her friends take cues from this? Did they?
Yeah, absolutely. I mean, not just her friends, even I have actually used this technique afterwards, where one sees some problem and one sees that adding one will actually help us get a very nice number, and help us generalize.
Yeah,
So even I
yeah.
have actually used it afterwards many times to solve patterns. So
Yeah, yeah. Learning from the learner, huh? That was Kritika's title. So let's move on to Kritika. And Kritika, can you share how you open up opportunities for students to, get talking in class?
Yes, I'll do that. Okay, can you see the screen?
It's coming on. It's coming on. Yeah.
Okay, so there are various ways of generating conversations in the classroom. One of the ways is choosing the most interesting mistake in the class and then starting the conversation. So I'm going to choose the area perimeter misconception part. These are some of the statements which can be provided in a worksheet or can be written on the board. And I have told the children to form a group and start doing the work together. So I'll share two examples by the students. So if you cut a rectangle in half, the perimeter will be half its original length. So this child has shown that she has taken a rectangle of 14 and 6 units. So the perimeter becomes 40 centimeter. So she has told that I can cut either lengthwise or breadthwise. She has shown here. And then she has cut it, halved it along the breadth and shown that the perimeter of the halved rectangle is 34 centimeter, which is not the half of the original perimeter. And she has concluded that it is not true.
Kritika,
This child,
Kritika, may I request you to
yes,
just keep that slide on a little bit so that people can see it clearly, because there's a lot of working on it. And maybe you could just repeat the steps again.
yes. So she has explained that whenever we are cutting a rectangle in half, either the breadth or the length is getting halved, not both of them together. So the perimeter is also not becoming half. That was the first statement she has written. And then she has given the example that a 14 and 6 units long rectangle, the perimeter is 40 here. So she has told that either I can cut it along the length or the breadth. So she has taken the example of halving it along the breadth. So the breadth is becoming 3 here, and hence the perimeter becomes 34. So which is not half the original perimeter's length.
Okay.
So she has
She's used an
concluded that
example too. Yeah.
she has used an example. And the next child, what he has done is a very common mistake. We find that he has halved both the length and the breadth. So first he has taken the length and breadth as 6 and 8, where the perimeter becomes 28. Then he is halving it, so halving the length as well as the breadth. So it becomes 3 and 4, and hence he has concluded that 14 is half of 28, and hence it is always true that it is half of the original length. So you see that if they are in a group, the first child can correct the second child. I don't even have to be there as a teacher to correct this child's mistake. So the peer group conversation also helps a lot to learn. So I just set the statement, and this happened. Okay. So this is another example, that a square and a rectangle, when both are having the same perimeter, but the square has the greater area. So this was the statement. So this child has taken 4, and so first he has taken the squares example where the lengths are 4. Here the perimeter and the area are both 16 for the square, and for the rectangle he has taken 6 and 2 units. So the perimeter's area becomes 16, the rectangle's area becomes 16, and the rectangle's perimeter becomes 16 and rectangle's area becomes 12.
12.
So he has concluded that it is always lesser than, the square and perimeter, if they have the same, the rectangle and square, if they have the same area, then the square's thing is always greater.
Perimeter.
But you see here, the second child, what she has done, I have found is very elegant, where she has started solving that let the perimeter be 200 for both the square and the rectangle. So if the perimeter is 200, then the area of the square becomes 2500. Now you have to understand that at this stage they do not know algebra, so they cannot do the generalization using algebra. But what she has done here, that since the perimeter is 200, then the rectangles 2 into L plus B should be 200. That means L plus B, that means length plus breadth is 100. Now, at this stage, I found this very interesting. What she has written, that there are many ways to divide 100, except for 50 and 50, because then I will land up in square again. So, except for 50 and 50, there are different ways of dividing 100 centimeter. But the first example, what she gave is wrong. 30 and 20 is not the correct example. So, she has written that 60 and 40 could work to make 100, and maybe she could have given some more examples as 80-20, 70-30, or something else, but she has chosen to work with the whole number length, not the decimal length. Then she concluded that the largest length and breadth, the combinations of the largest possible length and breadth, is 51 and 49. So this part I found it very interesting, that she must have got it by trial and error method, but she has chosen the highest possible combination. So 49 and 51, if I multiply, I get the area as 2499 square centimeter. So I see that whichever combination I take, that combination will be less than 2499 square centimeter, and hence the rectangle's area will be always lesser than the square's area. So I found this very interesting. Yes.
So do I. I think that is
Yes.
absolutely
Absolutely
fascinating.
fascinating. So again, it's a group conversation. I can give another example if there is time. Otherwise, I can stop this share here.
Please do. Please do. We do have time.
Yeah, so this is the last example which I wanted to show, that Anita says the area is always bigger than the corresponding perimeter, as it involves multiplication, because area involves multiplication and perimeter is just adding lengths. Now you'll be surprised to see the child who just explained elegantly has done a mistake here. What she has done is she has taken only one example of 25 and 15, a rectangle of 25 and 15. She has calculated the area for this and the perimeter, and she has concluded that the area is always greater than the perimeter. But the other child, he has taken two examples. One is a square of 4 and 4 length. Here the area and perimeter are both 16, so it is same, it is not less or greater. And another two, a square of side 2, where area is becoming 4 and perimeter is 8. So it is not true that the perimeter is having a smaller value than the area. So he has concluded that it is sometimes true. So again, in a group, if there are loads of different kinds of answers, then they can conclude by themselves that what is the correct answer without the help of the teacher. Yes, yeah. Thank you.
Thank you, Krittika. And I see from both of you that one of the key ways to get children talking was a careful selection of examples. The examples that you both selected were, had just the right level of difficulty. You accepted things like, for example, Aaloka was quite comfortable with not using N or typical algebraic language, but using number. But you were kind of moving towards generalization, both of you, with the kind of examples that you both used. So while you were getting children to talk, you were also familiarizing them with mathematics. I find that really very fascinating, because even things like always true, sometimes true, never true, and having a single example prove a case, and how when it was the exception, it proved the case, but when it was an example, it need not necessarily prove the case. I saw children learning a lot, and while having fun. And I think that the choice of examples always leads to good communication in the classroom. Would you both agree with me?
Absolutely, yeah.
Yes.
It really matters.
Yeah. So do you all do a lot of preparation before you go into class? Or over time, have you got a repertoire of examples which you can use?
Um, Ritika, you want to go
Some,
first?
yes, so sometimes, yes, these worksheets, I think that sometimes planning ahead helps, because in a class where the class strength is more than 40 or something, it always helps to plan ahead. And sometimes from their answers, the discussions start to take place. So that also happens. But planning a bit helps, I think.
Yeah, yeah.
Yes.
You cannot plan to the last detail, right? Because you don't know which direction it's going to go when you give the children the scope to think. Thank you. I have actually seen two benefits of getting children to talk. One was getting children to reason and explain and the other was surfacing misconceptions. So, have you both noticed any other benefits of getting children to communicate and talk in class? I'll go with Kritika first this time.
Okay. 1 minute. Okay. Is it visible?
Yes.
So this is the second area where we can start a conversation is that if we pose questions or design activities carefully, where the children come up with their own solutions and own definitions, before giving them the definition or giving them a rule or a formula, we can design such activities where they come to the formula by themselves. So I'm going to show two examples here. Is the construction screen opened?
Yes,
Did
it
it
does.
open? Yes.
Yes.
So this one is done in GeoGebra platform. This I had done before we started the construction of triangles. We usually tell the children that there are minimum three conditions like SSS, RHS, SAS, and so on, and to construct the triangles. So I thought that maybe they can find out by themselves that there need to be minimum three conditions to construct a triangle or to draw an unique triangle. So this was a simple activity where I asked them to draw a triangle where the sides of 2 units and 3 units. Here I wanted them to learn to draw in GeoGebra as well and try to draw a unique triangle. And then this question was asked that do you think an unique triangle could be drawn with the above information? And if not, then why? So they had to suggest that what else information should I provided to draw an unique triangle. And some of the responses. So first of all, this task was done in during the pandemic. So this I had a great opportunity to use the GeoGebra classroom to see their actual real-time feedback, which was not usually happening during the pandemic situation, where actually I could go around in a classroom and see that what they were doing. I could not do that. So but this GeoGebra classroom gave me that opportunity where I could see that what they were actually doing. So these were some of the trial and error. They tried a lot of different answers. And then task 2 was, if do you think an unique triangle could be drawn with the above information? So the yes and no, you can see now it is the yes is lesser than the no. But usually, I mean, in the beginning, it was almost same. They had the length, both A and B column had the same length. Later, task 3, when we started discussing task 3, here they had to give reason why the unique triangle could not be drawn. So I'll read out a few answers. For example, this child Kairavi, she has written that no, because I could draw two types of triangle, one right angle and one isosceles.
Nice.
This child, she has written very interesting thing that different people would extend the two arms of the triangle in different direction, and thus the third arm joining the two arms would be of a different measure of each and every person. So in the measure of the if the measure of the angle is provided, the two arms of the angle would only meet at a certain point, and for which the measure of the third angle would remain same for everyone.
Wow.
So yes. Then this child has written that I think a unique triangle cannot be drawn with only this information, because if we just change the angle of the two triangles, it will be different. So these interesting responses could, generated a very rich discussion. And then when I went to task 2, I saw that the column A was dropping than the column B. So that was interesting, that how they changed their perception and their answers after listening to their friends opinion. Again, I did not have to intervene here. Yes. So then another example of this kind is that before we start identity in class 8, like a square minus b square, we can give them this pattern. So 7 square minus 6 square, where the difference of two squares, the difference is 1 here. The gap between the two numbers is 1, and ask them to find what pattern they are seeing here. So instead of just calculating what is 7 square and 6 square and subtracting, we should insist them that without actually doing the calculation, can they see a pattern with bigger number as well. And they will soon notice that the pattern is adding the two numbers when the gap is 1. Now at this stage, again, you can break them up into groups or pairs and ask them to find out when the difference of two squares, the pattern in the difference of two square, where the gap here is 2, 3 and so on, not 1. And after loads of examples, they have to give plenty of time to create their own examples. I am not providing any examples, so they create their own examples. So here they have to create correct examples and make a conjecture, and with plenty of time they come to the conclusion that it is just the finding the sum, multiplying the sum and the difference of the two numbers. So this was also very interesting.
So
Yes.
did they put that into algebraic language?
Yes, because they are in class 8, so they could put it into algebraic language in the
So they
general form.
actually arrived at
Yes.
the difference of squares formula.
Yes, yes.
Okay.
Without intervening, just gave the example and they could they could come up with the solution.
And you felt that the group work and the conversation in the group helped them to
Yes, and
consolidate
also,
the motivations.
correct. Here also the rigor also is emphasized. Like they did a lot of calculation, right? So they took lot of examples and lot of calculations, but the time, we have to give them plenty of time to do that. Like we cannot be in hurry that they have to come to this answer at a very quick point of time. Yes.
Correct. And I particularly liked the way you set the foundation for that SAS congruency rule, with that activity that the child had almost, had said it without knowing that
Yes.
she was stating the rule.
Correct.
Um, so,
So it stays with them. I felt that when they create their own example or they come to a solution, a conclusion by themselves, it stays with them longer than if I tell them that this is what should be done and should not be done.
wow. Okay. So, Aloka, have you seen
Yeah.
any other benefits of getting children talking?
Yeah, but I would just wanted to say one thing about this culture of justification that I
Yes.
wanted to just clarify. I
Yeah.
feel that initially one really needs to work hard on asking them why. It's not easy because it's not something that is usually done. So in my case, for example, when I first started saying, they did not even understand the question why, because usually in mathematics nobody asks why
Hmm.
in
Hmm.
school.
Yeah.
So I think that was a very interesting place, and I mean we started from not understanding what why means to actually ending with children actually saying something and saying because. So that was something which was a very nice thing that happened, and they really wanted to do it, but it was just
Yeah.
something that they
Yeah.
needed to get
Yeah.
used to it. Yeah. So yeah,
You
I'll
both make
share.
it look so effortless, but I know there's a lot of groundwork and preliminary, spade work that needs to be done before we arrive at such a classroom. So I'm sure that all that you're sharing is of great value to our listeners. Please continue, Aloka.
Yeah, just give me a minute. Oh, can you see my screen?
It's coming on.
Yeah. Uh, do I continue?
Yes, please.
Yeah, yeah. So the second strategy that I had told you was open questions in approaches. So these are actually the same in the same lines as Kritika. It's kind of extension of. This was the question asked, that there was a table given to the children of numbers and squares, and they were told to think of whatever patterns they can think of, and verify whether their patterns hold for any natural number n. This is a really open question, and it's kind of it turns out to be a very open exploration. So this is a learning unit in the project Vigyan Pratibha I was talking about. So this was done in a class, and we so this was a planned classroom, and we did not know the students very well. There were class 9 students who had come for a summer school. And the reason I'm saying this is basically because I think sometimes it's not just the preparation that you do with the class, but also the task that you develop that itself has that potential of making it communicate in the classroom. So, yeah, so this was the question given, and so there were a lot of like children were asked to give some patterns. So, one of the first patterns was this, where the children drew the child drew a L, and they called it ulta L, L and upside down L, and they said that all the numbers in this L will give you this number. So, and then they kept on drawing it across, and they showed that for all the numbers from 1 to 20, this works. Now, when this pattern actually came up, I had never seen this relationship between square of a number and its presider and its square. But if I translate it into the words of the child, it is sum of the number, its consecutive number, and the square of the first number is equal to the square of the second number, which translated into algebra was just n into n plus 1 plus n square is equal to n plus 1 the whole square. Now, when I expand both the sides, I can see that this works. But I did not know this. I did not know this relationship when it first came. So that this was something which was a very nice thing, a new pattern that came across.
Absolutely. Yeah.
Yeah, so that was a very nice thing. Then in the same, so this was this was a set of two sessions taken by two teachers. So this is another conversation. So this child comes up with another pattern, and the pattern is that the numbers between square numbers are increasing by 2. So the teacher basically just expects him to clarify and says, what does that mean? So basically, he says that between 1 and 2, it is 2 and 3. Between 4 and 9, there is 5, 6, 7, 8. So then the teacher actually questions him and says, how do I know that, if I take a big square, how will I know how many squares are going in there between? Somewhere putting a question mark on what he's saying, and like not saying that I believe you in what. Now I would like to add that the teacher, of course, knew that this pattern was correct, because all of us know that the difference between any two consecutive squares is a odd number. So when you start counting the numbers between them, then you will have one less than the difference. So the teacher knew it, but she still questioned it and said that, like, how do I know that it is correct? So another student gets up and says it's correct. So then the teacher asks the second student now, saying, like, can you explain to the class? So he actually goes and starts clarifying, saying that this first pattern, that the two numbers are added in between, that is, his pattern has proved in the table. Then he says we see numbers between 1 and 4, there are two numbers. Between 4 and 9, there are four numbers. Between 9 and 16, there are six numbers, and so on till all the numbers from 20. And we can see that these numbers are 2, 4, 6, 8, and so on. So at this stage, I think the teacher was wondering what to say. I mean, ask him to uh, prove it, making it a point that it's not a proof. But before she could say anything, this one student just gets up and says, "But ma'am, this is not proving. This is just verifying." So I mean, neither did she have to support the pattern, neither did she have to negate the argument. It was all done in the classroom, so they were doing it amongst themselves. She was somebody who was just putting in seeds of doubt at the right places. uh, so this is one this so I'm all the examples are around this only. So this is just the same table but from 1 to 10. And so this particular incident happened in Usmanabad. It's a district in Maharashtra. And so this girl was asked, this students were asked this question, and this one girl comes up with this pattern, which she calls a V pattern. So she says, add 1, 4, 3, and then add 1 to it, and you get a 9. And
Hmm.
she says it happens for all numbers. So it's 1 plus 4 plus 3 is 8 plus 1, which is 9. So she puts it in words as, this is very complicated. The sum of the number, square of the next number, the number next to it, plus 1 is equal to the square of the number next to the next number. Uh, I mean, it's very surprising. I mean, at least I didn't even see how she got that pattern or how she reached that pattern. But when I put it, I mean, I also did not think that the pattern works when she first gave it. Uh, but when I put it algebraically, I see it works. It will always work for every x, because you just have to put it as x
Yeah.
plus 1 whole
Yeah.
square plus x plus 2 plus 1. So this actually always works. And but this is something which I had not even seen. I mean, I did not even believe it when I first saw it. So we when we so we went on to, so in the classroom what we had also tried to do was, when any child came up with a pattern, we named the pattern by the child's name. So this pattern was called Pratibha's pattern, because this was Pratibha who had come up with in this class. So in this class it was Pratibha's pattern, and this has happened across in a lot of classes like this. And I mean, one could see that the children really liked the idea that it was named after them or even their classmates, because there's a sense of ownership uh, that came up with this. So, I mean, to conclude, like what I would say is that, what we achieved with this open explorations and making it facility to for children to talk in the classroom, was there was new mathematics created by children. Some mathematics which even I didn't believe was correct. uh, the children really engaged in mathematical processes. So be it be conjecturing, be it be verifying, be it be proving, they were really engaged in it. It was something that they really liked to do. But for me, what is most important was that, like, the teachers stopped being the only source of knowledge or validation. So it was not that just be, so the teacher actually put a doubt. Even then, there was another child who came up and said, "No, I think this is correct. Even if you're doubting it, I think it's correct." Or somebody saying that when the teacher is not said anything, the teacher, somebody saying, coming in saying that this is not proving, this is verifying. So I think this is something which I really think that, it's possible when children talk in the classroom that these things happen. Uh, yeah. Uh,
That's
Thanks a lot.
pretty amazing stuff, Aloka. And I think that all of us are just longing to be in both your classrooms now. So we have some questions, but before that, I'd like to specifically talk about the articles which you wrote. So I will ask Kritika first, okay? Um, uh, in your article, Little Mathematicians or Learning from the Learner, you had one common question and then separate questions for each child. So, can you share a little bit about this? So,
Yes, I just
yeah,
share the screen once.
yeah,
Answer. Is it visible?
yes.
Okay, so yes, so this it was a written conversation. I chose this question from NCRT specifically to see that how their thinking is happening, because this could not have a straightforward answer like this is greater or that is greater. They had to provide some reasons for their answer. I had mentioned that they need to provide reasons, but many could not, and many did. And from there, we started the conversation. Actually, when I was reading their answers, I was amazed by the originality of the method taken by them, because the child was not preconditioned or restricted by the so-called knowledge of mathematics. So it was a very original answers, very original explanation, and they had their own logic and method, which I did not thought of. As Aloka was saying, that I we did not think that this can be approached in this manner, but it was a lot of there were a lot of approaches from different directions to the same problem. I'll share a few of the answers given by them,
Sure,
that how
sure.
in detail and in step by step format they had given it, although it was not taught in the class. This kind of questions was not done in the class. So she has written that since 100 is greater than 2, so 2 to the power 100 will be greater than 100 square. This was her explanation, and I could not resist asking her that means whenever the exponent is bigger, the number will be bigger or not. So for that she has given me these explanations, that written that yes, I have checked many examples and they are working. So she has given some examples, as 8 to the power 9, it is greater than 9 to the power 8. 11 to the power 13 is greater than 13 to the power 11. 100 to the power 125 is greater than 125 to the power 100. But now these are the conditions which I again liked. 2 cube and 3 square, it is not working, because I know 3 square is greater here. And also 1 to the power any number, or any
Wow.
number to the power 1, this will not work. Of course, 0 to the power some number and some number to the power 0 also, it will not work. So she has mentioned in detail that which are the conditions for which it is working and for which is not. Also, she has found a pair which she told that 2 to the power 4 and 4 square, they are having a same value. And then she has written also, though I did not find any other pair like this till now. So this was very interesting. And then this child also, this was since this was a written conversation, some of the children who usually do not open up in class discussions, they spoke, I mean, they have written a lot, and they had written very nicely. So I had the opportunity to hear those children also through these conversations.
Okay.
So again, here he has written that 2 to the power 100 is 2 into 2 into 2 so many times, so 2 to the power 100 is greater. And then he has explained it nicely, that he has clubbed it. So 2 to the power 100 he has broken up and written as 4 to the power 50. Now 4 to the power 50 he has written as 16 to the power 25. So applying the exponent laws, he has done that. And then he said that I just have to compare now 100 square and 16 to the power 25. But for that, he just told that 16 to the power 4 itself, I have done the computation and found that 16 to the
Wow.
power 4 itself is greater than 100 square. So, of course, 16 to the power 25 will be greater. So, this flow of thinking was amazing.
Yeah.
Yes.
Yeah.
So, that's all.
And I particularly liked your point that it was the quieter children who were able to share when the exercise was a written exercise. So clearly, we are not just talking about verbal communication here. We are also talking about any form of listening to what is going on in the
Yes.
child's mind. Yeah, yeah, great.
Yes.
So I am a little curious because Aloka, you co-authored this article with Mangal, and I understand that she teaches in a government school, right? So, do you think that children from government schools, children who are, who maybe first generation learners, uh, do you think that they are capable of problem solving at this level and
Uh,
thinking and conjecturing, justifying? Is this attainable by them? Is this possible?
Yeah, I think it's very possible, but maybe we can hear Mangal itself. So, because this discussion is in English, and Mangal was not very sure about that, so that is why she sent us a video. So I'm going to
Okay.
play the video, And if there's a problem, the video is in Marathi, but it has subtitles. If there is a problem, then I will also clarify the.
Yeah.
So let me just tell me if you can't hear me.
Yeah.
नगर परिषदेच्या प्राथमिक शाळेत कार्यरत आहे. माझ्या शाळेतील मुले मुख्यतः हातावर पोट भरणाऱ्या मजुरांची आहेत. काही मुलांचे पालक केसावर भांडे विकण्याचा व्यवसाय करतात, तर काही
I think there is a lag, so I may just hold it for it to load,
Yeah.
and then
Yeah. Let
could
it
you
just
hear it?
load. We could, and we
Yeah,
can see the
you could hear
subtitles
it.
also. Yeah.
Yeah. Yeah. So maybe now it will work.
मी मंगल पवार कोपरगाव नगर परिषदेच्या प्राथमिक शाळेत कार्यरत आहे. माझ्या शाळेतील मुले मुख्यतः हातावर पोट भरणाऱ्या मजुरांची आहेत. काही मुलांचे पालक केसावर भांडे विकण्याचा व्यवसाय करतात, तर काही मुलांचे पालक प्लॅस्टिकच्या टब, बादल्या, जुन्या साड्या घेऊन देतात. काही मुलांचे पालक फ्लॅट धुणे, बांधकाम, मजुरी अशी कामे करतात. गणित शिकवताना मुलांचे पूर्वानुभवाचा वापर करत गेले. या मुलांच्या घरात छोटे मोठे व्यवसाय सतत चालू असतात. शिवाय सोयीची पद्धत कोणती, ह्या निवडीचे स्वातंत्र्य
Need to load it a bit.
It's buffering. Yeah. It's buffering.
Yeah, I'll just wait for some time. So I can till then I'll just talk about the children, and then Mangal will of course clarify. So
Yeah. Yeah. Let it load.
yeah, yeah. So as you can see from the subtitle that is visible, Mangal works in a Nagarpalika. Nagarpalika is a local government. The Nagarpalika primary school in Kopargaon. Ahmednagar is the district, and most of the children come from daily wage earning families. They both economically and socially marginalized backgrounds. All the children, most children have economically and socially marginalized backgrounds, and so it's about yeah. So I don't know whether it's finished buffering. Uh, yeah, so this particular article comes from Mangal's work in her classroom. This was before the pandemic, and this this basically Mangal used to send me their working out either videos or audios, and this particular article comes from all the
Great.
collection that she did, all the evidences that she had collected of her children being able to like do things in the way that they did. So let me just try my luck again whether the video is loading.
मंगल
Yeah.
पवार कोपरगाव नगर परिषदेच्या प्राथमिक शाळेत कार्यरत आहे. माझ्या शाळेतील मुले मुख्यतः हातावर पोट भरणाऱ्या मजुरांची आहेत. काही नगर परिषदेच्या प्राथमिक शाळेत कार्यरत आहे. माझ्या शाळेतील मुले मुख्यतः हातावर पोट भरणाऱ्या मजुरांची आहेत. काही मुलांचे पालक केसावर भांडे विकण्याचा व्यवसाय करतात, तर काही मुलांचे पालक प्लॅस्टिकच्या टब, बादल्या, जुन्या साड्या घेऊन देतात. काही मुलांचे पालक फ्लॅट धुणे, बांधकाम, मजुरी अशी कामे करतात. गणित शिकवताना मुलांच्या पूर्वानुभवाचा वापर करत गेले. या मुलांच्या घरात छोटे मोठे व्यवसाय सतत चालू असतात. शिवाय सोयीची पद्धत कोणती, ह्या निवडीचे स्वातंत्र्य त्यांना सुरुवातीपासूनच देत आले. तसेच समस्या टाकणे, जसे 45-22 ही वजाबाकी साई तोंडी तसेच एककातून एकक व दशकातून दशक काढून करत होता. पण 43-27 ही वजाबाकी त्याला करण्यासाठी दिली. तोंडी वजाबाकी त्याने केली, पण एककातून एकक कमी करणे या पद्धतीत तो अडचणीत आला. त्यातून बाहेर पडण्यासाठी तो प्रयत्न करू लागला. घरच्या हिशोबाच्या पूर्वानुभवाचा उपयोग त्याने केला व स्वतःची एक वेगळी पद्धत त्याने शोधली व उदाहरण सोडवले. 40मधून 20 गेले, 20 उरले, 20मधून 7 गेले, 13 उरले व 43मधील 3 त्यात मिळून त्याने 16 उत्तर काढले. सोयीची पद्धत, समस्या टाकणे, त्यांच्या घरच्या पूर्वानुभवाचा वापर हे 3 सूत्र वापरत गेले आणि वेगवेगळ्या पद्धती समोर येत गेल्या.
So, yeah, sorry about the lag.
No, I'm
So-
really glad you shared that. More power to Mangal and teachers like her. Yeah, Aaloka, you were saying something.
Yeah, so I mean, I will just kind of try to summarize what Mangal said because people might have missed out of it because of the subtitles. So, Mangal is a teacher who works in Nagarpalika Primary School in Kopargaon, Ahmednagar. So her teacher, as she says, most of the students in her school, not just her class, come from uh, Delhi wage work earning families. Uh, so they do this. I mean, a lot of activities like selling plastic buckets and mugs, or something that is like in exchange of hair, they buy utensils and then sell the hair to, I think, wig makers, or laborers and construction workers. So what she was saying was that one of the three things that she does to get her children to talk is that she basically keeps on posing problems to them. Also gives them the choice of picking up a convenient method to solve problems. So instead of saying that you have to solve it for only in this way, she actually gives them the freedom to solve it in whichever they want to. And she kind of recognizes that they learn a lot in their homes, where there are these small calculations that they see because of the small businesses that their parents are a part of. So she sees this, they see these calculations and they learn from those calculations. And so basically what she's saying is that so even when she's saying that even if it's 45 minus 22, Sai does it in two ways. So in one way is what the classroom has taught him, that tens one, like, subtracting tens from tens, ones from ones, and you get the answer. But then when she gives him a number like 43 minus 27, that particular method of subtracting ones and tens fails him. And there he just remembers something that happens in the everyday calculations that he had seen, where basically what he says is that I'm not going to look at 43, I'm just going to look at 40. So he, like, from 40 he he subtracts 20, he gets a 20. Then from this 20 he again subtracts a 7. So he gets a 13, and the 3 of the 43 he just takes and he gets a 16. So
Beautiful.
so she says that, she ends with saying that the three things of giving problems, giving them the freedom of choosing their own thing, and always recognizing their prior knowledge and prior experiences is the reason why answers and methods just kept coming in her classroom. So that's how she ends the conversation. Yeah. So yeah, I didn't. So
Thank you so much for sharing that, Aloka.
I
I
and
am going to move into the questions, and
yeah.
I'm actually going to start with the last question from Garima Gupta, who, because it links to this video, it says, does the social background of the children play any role in development of mathematical communication? You have answered that in part, but is there anything more you would like to add to that? Does the social background of the children play any role in development of mathematical communication? So I think what we're saying is what you started with, that they may not do this in the beginning,
Yeah.
and is their social background also holding them back from communicating, or is this common across all children, that you need to build the skills of mathematical communication in them?
See, I think communication is are very different aspects. There are different aspects of communication. I think confidence is one thing that is absolutely necessary to be able to talk in the classroom. And I think that is definitely, I mean, when if you come from marginalized backgrounds, and that confidence is something which is not there, and that needs to be built up by the teacher. And I'm giving that space. And I think, for example, even in the videos that I listen to Mangal, children talk to her. So they call her Tai, which means elder sister, and not teacher or Bai. Yeah. And one can see that she has worked towards getting that confidence for them to talk. Uh,
Yeah.
I mean, my own experience in Madhya Pradesh also feels that if you give that confidence, it takes time, and it takes time, but they definitely come there where they start talking. So yes,
Okay. So you're
it
saying
matters,
the
but
classroom needs to be set up as a safe space to talk.
yes,
Yeah.
absolutely.
Yeah. Kritika, would you like to add to that? Because I can see that this applies to all kinds of students, that setting up the safe space. Is there
Yes,
anything?
so
Yeah.
yeah, so a lot of time needs to be given, and we have to, uh, say them that's a safe place to make a lot of mistakes and lot of errors. They should not be afraid of making mistakes. So the moment they're afraid of making mistakes, there we stop the conversation part. The communication stops there. So if you are only worried about right and wrong, ma'am, is this right, or ma'am, is this wrong, then there is no conversation which can happen. So we have to stop there. So it is all right to make mistake, make lots of mistakes. It's all right. So I
Yeah.
think
And I like the way you harness the misconception as an opportunity. It surfaced, but then it kind of self healed with the
yes,
discussion. It was not like you were saying you are wrong.
correct.
You were taking it as an opportunity for discussion.
Yes.
So we have similar questions from Garima again and from Sunita Bhatia. I'll read out both the questions. Okay. Garima says, what kind of pre-practice children went through before getting to express and communicate so fluently? And Sunita Bhatia says, what type of prior practice is required for children to express and communicate confidently in primary classes? What kind of prior practice? So, who would like to go first? Aaloka?
Yeah. I think prior practice I mean, for children, I think it was, at least my experience says that just, as I said, it's a space and a lot of more opportunities of solving with no judgment, as Kritika said, that, there is just no right and wrong, or you jumping to right and wrong. And it's, I mean, I would actually say that even like, in a lot of times we didn't even discuss whether what they said was right or wrong. It was just sometimes when you start giving reasons, you yourself realize that there's a problem in what you're saying. Children themselves realize. Uh, which we could also see some in some of Kritika's examples, where they started understanding that when they got more examples, they understand that there's a problem. So yeah, but I mean, I think that uh, giving them space, and then opportunities to do more and more of it, and not losing patience. I think that is extremely crucial. I mean, and not easy, but not losing patience. I mean, I think I mean, especially in this online classes, I see myself also lose patience, because uh, at least when you're in the physical classroom, you see expressions and you know that that they are thinking. At least in this online thing, it just, one doesn't know what is happening. There's just a void of silence. And I mean, I have got nervous. I've seen teachers get nervous. So I think patience is definitely something which is very crucial on the teacher's part. Space and opportunity and patience, I think. Yeah.
Yeah. And is it okay to be okay with silences? To just say, okay, let me just
Yes.
wait till somebody breaks it. Let me not rush in. I think that is a mistake that I, as a teacher, used to do, wanted to break the silence first. So, yeah, Kritika, maybe you could specifically talk about primary and upper primary classes. Is there anything that you would specifically do? Do you find that children in primary classes talk more than the ones in the upper primary, maybe?
Yes, that is there because they have many questions and they have many things to say. So I think in primary classes we have more opportunities, and I think there are much more time in the primary classes to explore different methodologies to work with. So we can bring in many play games and many other things to introduce. Somebody asked that question related area perimeter starts from classes 4 and 5. So I think we have to give them the space. Suppose they have to know that what is the area, so we should not tell them the area is length into breadth. So we give them enough time to figure out by themselves that why the area is length into breadth, so they can work with a geoboard, or if not geoboard, then they can work with dotted papers. So on the dotted paper they draw the rectangle and the square, and then count how many squares, unit squares are there in each rectangle and square, and from there they generalize at the end that the length into breadth gives the area. So if we do a lot of these things, then I think the fluency comes automatically. They are not fixed by any idea that this is it.
Yeah.
I mean, we have to
Yeah.
approach in this. Yes.
That was Umar's question that you answered.
Yes,
Th- uh,
yes.
that, yeah, thank
Correct.
you. And we have one more question from Sombit Guha, who says, does logic play an important role in solving a puzzle? A question from a puzzle lover. And do puzzles help in everyday life? So, anyone who has an experience of taking a puzzle into a classroom, do you think that it helped
I
in
think
any?
it helps in developing the logical, thinking sense, the progression that that it should not be a random trial and error. So when we do trial and error, the trial and error also has some logic in it.
Ah,
So that way, logic helps. I mean, puzzles may help to narrow down the trial and error path
yeah. So initially it is just hit or miss, and then a strategy starts evolving in the trial and error. Yeah.
around.
Aluka, you want to add anything to that?
No, I mean, I actually just wanted to say that puzzle is, any question can actually be made into a puzzle in some sense.
Huh.
Like the whole matchstick things, for example, I started initially as puzzles. Like,
Huh.
so what would be the 120, how many matchsticks in the 126 toe? Or
Huh.
something like that. So that was a
Huh.
puzzle which they had to. So I personally feel that puzzle is a very, I mean, it's a much larger spectrum of things, and
Hmm.
some of them definitely help. Everyday life, I don't know, but
Huh.
mathematics they help. So
Yeah. 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 So we have a lot of thoughtful comments on the comment box, and I think people generally are, agreeing with you that it is the questions, and they need to contextualize mathematical problems with daily life experiences of children. Questioning technique of teacher is useful to make the student communicate. So I think you've struck a chord with our listeners. Thank you both so much for sharing of your experience, and we look forward to more articles from both of you. Thank you very much.
Thank you.
thank you,
Thank you.
Sneha.